that, as we probably all know, managing a project is very complex, but it's even more complex when it comes to an open source project, because you need to manage the team. You have a lot of contributors, and most of them you will not know, and so you want a way to maybe welcome them. You want to have a way to manage your issues, to label them, to do triage, and a lot of other tasks that usually people do manually. And if you have a small open source project, it's not a big deal. But if your project start growing, then it's when the problem may start happening, and it may be overwhelming for the maintainers trying to manage the project and in its entirety. For this reason, recently, well, not super recently, but in the last months, GitHub introduced GitHub Actions, and most specifically the V2 of GitHub Actions, because GitHub Action has been there for a while already, but the V1 was written using a different language, and you should use it using a different language. But this is being completely revamped and completely, basically redeveloped from scratch to have now the GitHub Actions V2. Now, most people think that GitHub Action is just a CI system, and in fact, it's the #1 CI system in GitHub for both public and private repositories. And it used to be, Circle CI used to be the first. Now GitHub Action is actually the first before anyone else. But that's not enough, because GitHub Action, yeah, it's a CI system, but it's much, much more, and it's a very powerful automation engine. Basically, if you can automate something, then you can do it with GitHub Actions. I will not have too many slides. I'll prefer going to the demos, but I want to introduce some concept first. So first of all, GitHub Actions is fully integrated in GitHub. There's no additional component to install. There's nothing to trick. It's just you start using it straight away. And as I said before, is a complete automation system. And to prove that, actually you can respond to basically any GitHub event. Now there's more than 90 GitHub events that you can respond to with an action. And as an event, I mean, for example, of course, when you push your code to your repository, like any other CI system, but for example, you want to do something whenever your contributor open an issue, or maybe you want to automate some flows in your pull requests, and so on and so forth. Or maybe you want to schedule something to happen every day or every night, and so on and so forth. As I said, there's more than 90 different events that you can respond to with GitHub Actions. Another very cool thing is that the majority of the workflows for actions are actually community powered. Of course, GitHub has available a set of predefined, like kind of certified actions and workflows that you can use in your workflows, and also some starter kits. But the greatest majority of the workflows and of the actions are actually community powered, and they are all open source. Even the GitHub ones are fully open source. And as a CI system, you can of course target any platform, any language, any cloud for deployments, for example, or even on-prem if you want to. And as such, they run on different environments. We have GitHub Actions that run on Linux. We have GitHub Actions that run on Mac OS. And this is super important if you're having like a project which comprises also a mobile application, for example, or an application for Mac OS. And the only way to build that is using Mac OS. Of course, they also run on Windows. But another cool feature is that you can also provide your own containers, which means that when you if you create your own GitHub Actions, or if you use a GitHub action, that can be written in JavaScript, for example, or can be contained in a container. And in that case, you can have any dependencies you need, anything you want installed in that container. So there's no limit, basically, of what your GitHub action can do. But still having the same flexibility and the same, it's as powerful as the native ones because they both have access to all the APIs that GitHub has available. Another thing that here is referred as the metrics builds, but of course they don't really work only for builds. They work for any kind of action you may want to build or to create, and basically give you the chance to execute different jobs from different contexts just with one GitHub action. So you write it once, you define the matrix, and then you can execute that for as many value we have in the matrix. And I have a demo about this in a second. They have very powerful logs. And again, those are not only for CI, but for all the execution of your GitHub actions, which are streaming in real time. They are searchable. And of course, you can link to any of those logs at any point in time. Will not be an automation system if we wouldn't handle secrets. And GitHub Actions has, of course, a built-in secret store, which may be a little bit basic for some scenarios, but it's very robust. And last but not least, since it's GitHub, they are actually easy to write and very easy to share. And in the end, it's just a YAML snippet that you can very easily share with anyone else. That said, let's go to the demo. So first thing I want to show here is that all the GitHub actions are stored in your repository and in these .github/workflows. And even though you create your actions from the actions menu up here, all your workflows will actually live in this .github/workflow folder. And here I have few workflows that I want to go through with you today, starting from CI, but then expanding to more complex scenario. The first one is this Dotnet Core Ci, which is, very easy to understand and basically happens on both push of the code or any pull request targeting the master branch. And one thing I've done here, since I have multiple applications on the same repository, is filter that by path. So I'm not filtering only by branch, but I'm filtering by path. And since this is a .NET Core CI definition, I want to build only the .NET Core web application, and I want to invoke this only when something changes in the .NET Core folder. Another thing I can do is defining a variable, and this is how you do it in GitHub Actions. Now, if you can see here, I have this variable definition, and I also have here another variable definition. And this is because GitHub Action allow you to scope your variable in different scopes. So defining a variable before all the jobs basically makes that available to any job that you have below that. But as you can see here, this csproj name variable will be only available inside the build job. If I have another job, in this case I don't have any other job, but if I would have another job after the build job, this csproj name variable will not be available in that job. So it's scoped to the current job. And as you can see, this is just YAML. I'm not a super big fan of YAML, but I know some people are, and it's basically now the de facto language for all the basically CI system or all the configurations and everything. So that's what we get, that's what we have to use. But it's very easy to read. So what happens in this action is just a series of steps, and each step performs some action. And in this case, as I said, is a CI definition. So we are just checking out the code, making sure that .NET Core 3.101 is installed on this runner, and then do whatever the .NET Core build requires. And if you go up here, again, we have the csproj name variable and the folder name variable. And if you want to use them inside your definition, you can either use something like this, so $, name of your variable. But if you want to be a little bit more, compliant, if you will, you can also, format and concatenate strings with using some expressions and functions like here. And the way to use any function in GitHub Action is prefix them with $ and the 2 parentheses, and then of course close the 2 parentheses at the end. These notation here and this notation here are basically equivalent, but it is much safer for any kind of variable type and variable value that you may you may have in your variable. So not too surprising here. This is very similar to what, for example, Azure pipelines look like if you've seen that before, and other CI systems. So if we go back to our workflow folder, and let's go now to this Node.js CI definition. Now again, it's still a CI definition, but it's slightly different. One of the things you want to normally do with Node.js applications is testing them or building them against different version of Node. The first part is the same as before, filtering by path, always using both push and pull request trigger on the master branch. But the different thing is here. So inside the build job, apart from defining that it runs on Ubuntu in this case, let's keep this for a second. I'm defining a strategy. And in the strategy, I have my metrics. And the metrics saying basically that this variable, node version, which is something that I define, is not something that is already defined in the GitHub Action language. This variable has this value. And this value is, in this case, an array of Node.js versions, but can be arrays, can be even more complex type. And what that does is basically repeating all the steps you can see here for each of those variables. And in this case, what I do is using here the matrix with the expression as we've seen before, and basically make sure that only that version that is specified here of Node.js is installed on that runner, and therefore compiling and building and testing these against the different kind of Node.js, the different version of Node.js. So if you see here, I only have one job, the build job, and I only write the steps once. But if I go back to the actual run of the action, I can see that it actually executes 3 times. Once for each of the variables I have, one for each of the values I have in my matrix. And automatically you also add this number in the job name. So I can immediately see, for example, if the version 14.x fails, I immediately know which one is that. Let's go back to our workflows. And that was a very easy, a very simple way to use matrix. Another and last thing I want to point out in this definition is this working directory, right? As I said before, I have multiple applications in my repositories. So one way to, instruct all the steps on what to do is, I can put in the actual steps the folder I want to work on. But that, of course, it's okay if I have only a couple of steps, but if I start having a GitHub action with tens of steps, dozens of steps, I don't want to repeat that for each of all the steps. So I can define in here some defaults that will apply to all the steps in that specific job. And in this case, the default I use is a system variable, which is working directory. And this is actually the folder in my repo where I want this runner to set its root folder. So it's pretty clean. It's pretty understandable. It's very readable, and this is probably one of the only advantages of YAML. Let's go back to workflows and go to something else. So as I said, GitHub Actions are not just for CI, but for example, we can do many other things. One thing that is very on the top of all the discussion today is doing DevSecOps. I can do that with GitHub Actions. Now, if you remember before, this is one thing I wanted to point out. Before we had the push and pull request on different lines with just prefixed by a dash. And this is another way you can define that. You can always, whenever you need to pass an array or multiple values, you can use either this notation with the square parentheses and just use the comma between the different values. Or, as we said before, you can use as we've seen before, you can use the dash value. It's completely equivalent. Now, in here, for example, I can do everything related to DevSecOps. One of the very important principles of DevOps on DevSecOps now is shifting left on security. You want to be sure your code is safe, is compliant, and doesn't have any vulnerability before even committing or before even creating your commit. And you can do this in this case. So these run, for example, on pull request. So if you validate your code here, you will be sure that your code, even if it's vulnerable, will never reach your master or main. I have just a couple of things here just to show few things. But again, there's literally hundreds of thousands of GitHub actions you can use. So basically, there probably be 99% GitHub action already built that allow you to use your own tool. For example, if you use Sonar Cloud, you have the Sonar Cloud GitHub action. You can use some secret scan. These allow you to scan your code for secrets, and if any secret is found in your code, this will break the run. You can check for passwords. You can even do an antivirus scan. And these are all open sourced, so you can see, you can go and check what they do and be sure that they don't do any malicious to your code. One thing I want to show here is we've seen before that I can have variables in at workflow level. I can have variables at job level, and I can even have variables at single step level. But one thing is here is that these variables, of course, will be used by the GitHub action defined here. For example, the Sonar Cloud action needs to have two things. It needs to have the Sonar token, which is basically the key for Sonar Cloud that basically say, okay, I'm licensed. And then needs to have the GitHub token, which allows the extension, the GitHub action to work on your repository. I want to show this because these are two, even though they look the same, they are two different things. In fact, this secret.github token, it's out of the box, and it's something GitHub generates for you, so it's not changeable, and it actually is refreshed at any run of any GitHub action. While this Sonar token is something that I created, and I can show you how. If you go back to the repository, you can see that in the settings of the repository, you have the secrets part. And in here, as I said before, you can, is where you store your secrets. And in this case, I created this Sonar token secret that it's, I cannot, even though I've been the one creating it, I can't even read it. I can only remove it or update. And if I do update, I can change its value, but I cannot see its value. This is a security feature we have. And even in the logs, if you try to log out this Sonar token, that will not be logged out and will just be covered with stars. Let's go back to our workflows. And let's see something that is completely unrelated to code. The first one I want to show is about the metrics. And this, for example, has nothing to do with pushing code or pull requests or anything. It's just a schedule, and these run every 5 minutes. And this, what does is simulating of a dynamic matrix. So in the example I had before, the matrix was previously populated at GitHub action creation. so the values are fixed. But in this case, I can actually populate my matrix with whatever I want. So in this case, I simulate having like a job creating a file list, and then maybe I want to do something on these files in the second job. So what I do, I just define here the matrix, and the output, basically this variable will be the output of this job. I can set the value of the matrix here with this syntax, and then in the second job or in any other job, I can actually use this variable using this syntax as a matrix for the strategy. And again, if I go back and check what that does, in this case, I only have 2 different files. So if I go in the run, I see that I have job 2 repeated twice for file 1 and file 2, and all the variables are taken from the matrix that have been automatically or dynamically generated by the previous job. I have 2 more things I want to show. The first one is these greetings. This is very, very popular, and it's actually a first-party action, and you know because the value here is action /. This means that it's a GitHub certified or GitHub first-party action. And what that does, again using the GitHub token secret here, it allows you to issue a message whenever a user opens his first issue or their first pull request. And you can provide literals, or you can even provide YAML multi-lines with markdown formatting. Going to see what that does, this is the first issue that I open on this repo. And as you can see, after opening the first issue, I have this comment from GitHub Actions saying, thanks for opening your issue, blah, blah, blah. This is completely, of course, customizable, but it's just a few seconds after opening my first issue, I received this command. And same thing for pull request. This was the first pull request I've created. And as you can see here, apart that I had a typo in the markdown formatting, so this is not being formatted correctly, but it's my fault, not GitHub Action fault. But all the other formatting is actually there and can be used, or basically any markdown can be used for this, even links to files and everything else. And this is very, very helpful. Last thing, last thing I want to show is this other workflow, which it's very helpful if you're using a mix of GitHub and Azure DevOps, because you can, with this syntax, basically on issues and taking in consideration open, edit, delete, and all the other events that you can do on an issue, you can automatically update your Azure DevOps board with the content of an issue or closing an issue. Of course, it requires some configuration, especially the personal access token for GitHub and Azure DevOps. But this is a very powerful way to keep in sync Azure boards and Azure DevOps. I'm almost out of time, so just let me recap what we said so far. Oh, and by the way, you can find the code I've been working on the link you've seen here. Is github.com/newton/HKOSCon2020. So again, GitHub Actions allow you to automate basically any workflow. You can do deployment, even though, to be fair, it's not super mature yet, but you can do anyway deployment. You can, for example, create tickets on Jira or on Azure DevOps. You can publish a package to NPM, which, by the way, is now part of GitHub, and much more. There are millions of open source libraries you can use, and as I said, you can create your actions in either JavaScript or using a container with basically anything you want, and both have access to the same API. We have very rich live logs, and most importantly, they are completely free for public repositories. You don't have any limit in minutes or executions for public repos. And for private repos, you have 3 minutes in each plan. Even in the free plan, you have 3 minutes for your public for your private repositories, but of course also in the GitHub Enterprise, etc. So you can get started with your GitHub Actions for free in private repositories. And with this, I've finished. Thank you for the attention. Feel free to hit me up after the conference in any of these links, and continue to enjoy the conference.